Okay, let's look at this rational functions worksheet number 1. So I've typed an equation into Desmos and got this graph. And I want you to analyze it so that you can actually come up with the equation. So the first thing you need to do is determine the x-intercepts, their multiplicity, and the behavior. So it looks like there's an x-intercept at -3, so that means -3, 0. It looks like it bounces off of that, so it's a bounce, which says the multiplicity has to be 2, or 4, or 6, but we'll stay with 2. It also looks like it bounces at 2. So that means it's a multiplicity of 2. Now what that tells me so far in the equation, the numerator tells me the x-intercepts. So if it goes through -3, the factor must be x plus 3, and it must be squared for it to bounce at -3. And to bounce at 2, in the numerator, we have to have an x minus 2 bounce. Now, it could be 4, but I'm keeping it simple here. Okay, the next thing I asked you to do was the y-intercept, and that looks like it's at 0, 6. And then I asked for the vertical asymptotes. This one's angling over more, this one's going pretty straight up and down, so I'm guessing it's at x equal 1. And I asked for the multiplicity, which is given by the behavior. Now at vertical asymptotes, we're looking for whether the function as we get closer to 1 from either the positive or negative side, what does this graph do? Well, both branches, or the graph on both sides, head up. They both go in the same direction. So if that happens, if they're in the same direction, the multiplicity has to be even. So is even, and I'm guessing is 2. To cause an asymptote, there has to be something in the denominator. So if it's at 1, that must be x minus 1 as the factor, probably squared. There's another vertical asymptote. Looks like this one's angled this way, so it's going to keep going over. The top gets closer and closer. Looks like it might be at 3 that this angles to. So it looks like it's at x equal 3. And in this case, as we approach 3 from the negative side, this one goes up. As we approach 3 from the positive side, this one goes down, so they go in opposite directions. So that means the multiplicity is odd, probably 1 in this case. Opposite directions, so multiplicity 1. So that means if it is truly at 3, x minus 3 is the factor, probably to the power of 1. Okay, now I ask some other questions here that don't help with the equation. What is the domain? Domain is for what x's does this graph exist? Well, from -infinity up to 1, there's a graph. So the domain goes from -infinity, always read it left to right, -infinity up to 1. There's an asymptote at 1 that appears, so that we would not include it, parenthesis, union, then the graph starts again right after 1, and continues on till 3, where there's another asymptote. And then after 3, it continues on. So union from 3 on to infinity. The thing that could mess up a domain is if there was a hole. It could cause another gap in this. I didn't put any holes in this one because they're hard to graph, hard to see them on the graph. What's the range? Well, this graph goes on down and down to negative infinity. It comes up, reaches a local max, and then goes down. So it looks like that's a little bit below 8.5. So I'm going to call it negative 8.6. So it goes from negative infinity up to negative 8.6, and then head back down. So I've got all those values. And then going up further, again, you read left to right when you're doing domain, negative to positive, we're doing the range, negative infinity up to negative 8.6, and from 0 to infinity, there's graph. Union 0 to infinity, and it includes 0. I might include 8.6 if I knew it exactly. So I'll put a bracket on it. But it's an estimation, so this bracket's iffy. I know for sure this hits at 0. Okay. And when is this graph? When is the y values greater than 0? For what x's are the y values greater than 0? Well, the y values are greater than 0 all the way up to negative 3. So I put in from negative infinity, the x values from negative infinity to negative 3. For those x values, the y values are positive, greater than 0. And then from negative 3 to 1, they're positive. Negative 3 to 1, the y values are positive. And then from 1 to 2, they're positive. From 1 to 3, I should say, they're positive. From 1 to 3, they positive. 1 to 2, sorry. 1 to 2. At 2, it's 0, so I have to skip over 2. So I go 1 to 2, union, and then 2 to 3. Can't include the 2 because I didn't say equal. And then the rest of the y values are negative. So that is the solution for when f of x is greater than 0. Local maximums, that's negative 8.6, my estimation. And local minimums, there's 2 of them. Both of them are 0. I'm noting that it happens in 2 places, at x equal negative 3 and at x equal 2 if I want to, but the minimum is 0. Now, if I said what are the points of these, then you'd have to figure out the x and y for that point for the local maximum, and the x and y for those 2 places. That's the front side. Back side. Now, to do this one, we need to factor this because the factored form really tells us a lot. So to factor this, let me turn this light on. This will help, I think. I'm going to turn on my calculator, and I'm going to clear everything. Go turn that plot off. Come down, and I'm going to type in x to the 3rd minus x squared minus 4x plus 4. And I'm just going to graph the numerator. Let's go. Hopefully I can see it all in zoom 4. Oh, it looks like it goes through -2, 1, and 2. That tells me that the factors are x plus 2 for the -2, x minus 1, and x minus 2. And if I multiply those, I get 1x to the third. So that must be the numerator completely factored. Now let's do the denominator. So I got to type it in. I'm going to put that in y2 so that I don't have to type this all in again. 2x to the fourth minus 14x to the third plus 26x squared plus 6x minus 36. So I want to just look at that one, so I'm going to push graph. And it crosses at -1. So the factor of the denominator is x minus 1. It crosses at 2, so crosses at -1, so it's x plus 1. Crosses at 2, so it's x minus 2. Crosses at 3, actually bounces at 3, so x minus 3 squared. So this is all doing what we did in the last section, Unit 2. So this helped me factor this. Oh, except for there's a 2 here, and this would have a 1 in front of it, so I have to have a 2 down here. So now I have it completely factored. Factored the numerator and denominator. I wrote it up here, but you got the idea. So I could have written this down here, x plus 2, x minus 1, and x minus 2, and over 2 times x plus 1, x minus 2, x minus 3 squared. There it's in factored form. Are there any wholes? Well, if there's any factor in the numerator that matches the denominator, 1 for 1, that would create a whole. Now, if they weren't equal multiplicities, it wouldn't be a whole, or could be a whole. It gets messy. But if they're just single ones like that, there's going to be a whole at 2. And to find the y-coordinate, I'm going to use a function that's close to it, but not exactly the same. It's approximately the same. The reduced form, it's going to be x plus 2, x minus 1 over 2, x plus 1, and x minus 3 squared. So if I put 2 in there, I get 4 times 2 minus 1 is 1 over 2 times 2 plus 1 is 3 times 2 minus 3 is minus 1 squared is 1. So I have 4 over 6, which is 2/3. There should be a whole at 2 and 2/3, that point. Vertical asymptotes. Well, there's a vertical asymptote. Since this was a whole, it won't be a vertical asymptote. There's a vertical asymptote at x equal minus 1, because the denominator determines the vertical asymptotes. And the behavior, since it's only a multiplicity of 1, it means it's the the branches of the graph will go in opposite directions, one up and one down. Okay? That's the behavior of the function at the vertical asymptote, that one. And there's one at 3. And since its multiplicity is 2, they're going to go in the same direction as it approaches x equal 3, they're either going to both go up or both go down. They go in the same direction. Is there a horizontal or an oblique asymptote? Now, if the degree of the numerator is less than the denominator, it'll be horizontal at 0. If the degrees are equal, it'll be the ratio of the leading coefficients. And if the numerator is greater than the denominator by 1, it'll be a slant asymptote. In this case, the degree of the numerator is less than the denominator. The denominator will grow bigger than the numerator, and it'll make it go to 0. So there's a horizontal asymptote of y equal 0 because degree of numerator is less than the degree of the denominator. Okay. Determine the x-intercepts. We did. X-intercept at -2, and it happens once, so it's straight through. It happens at 1. Multiplicity is 0, so it goes straight through. And this was a hole, so that's not an x-intercept. So those are the only two x-intercepts. And the y-intercept, I go back to, that's easiest in the original function. If you put 0 in for the x's here and 0 in the x's here, you get 4 over -36. Put in 0 in for the x's, we get 4 over -36, which is -1/12. No, 1/9. 4 over 36 reduces to 1/9. Bad. Okay. So I could, with this information, actually sketch a graph. And I will. We can actually type that in the calculator and you can see what it is with the technology. And that's what I say to do, but I'm going to sketch it without the technology, and hopefully I'm somewhat close. It goes straight through at -2. It goes straight through at 1. So there's an x-intercept there. There's a hole at 2 2/3. So if that's 1, 2/3 is not quite there. So there's a hole there. There's a vertical asymptote at -1. And it goes in opposite directions at this one. And at 3, there's an asymptote. And it goes in the same direction. X-intercept is at, or y-intercept is at -1/9. So the graph has to go this way. And since it goes in the same direction, it has to come this way. And when we get really big, it heads towards 0, the horizontal asymptote. And if it goes here, and it went the same direction at this one, both went up, same direction. They go in opposite directions at -1. So this one must go down because it doesn't cross in here. So it must come from above and come down through there. And after it goes through there, it has to come back up and go towards 0 because it goes towards 0 when x's get really big or really small. So when is the function less than 0? Well, it's less than 0 from negative infinity up to negative 2. And it equals 0 there, so we don't want to include that. Union, it's also negative from negative 1. Can't be at negative 1 because that's an asymptote. Up to there where it crosses, which is at 1. And at 1, it's equal to 0, and we don't want equal. So that would be it, and the rest of it's all greater than 0. So that would be when it's less than 0. And determine when it's increasing. Well, now we have to find that low spot in here because it increases from there on. So we have to figure out where that is. And I can't see that very well on the calculator. If you were in a calc class, there's another way to find that. It also increases for all of this except for the whole. So I can do this part. It's increasing from negative 1 to 2. It disappears at 2. Then union F, after 2, it's still increasing up to 3. After 3, it's decreasing. There is a portion here from some place up to negative 1, it's increasing. I got to find that low spot. So now I will have to type the equation in. Well, since I have these two in there, it's pretty easy to do it on a calculator. And you can also, if you wrote this as f of x equals this, g of x equals this, you can do f of x divided by g of x. On the calculator, we can do vars, which is here. I can do second vars, vars, not second vars, but vars function y1 divided by vars y2. Enter. And that will graph that. Now, I don't want to see these anymore, so I'm going to mute them so they're not showing. And now it'll show me this function, the original, this function here. So I'm going to push graph. You can see there was a hole. It does this, and it goes down and then gets closer. So you can't see the minimum in there, but the calculator can find it for us. The minimum is somewhere in here. So I'm going to go second, calculate the minimum. That's somewhere between -5 and -2. And I'm going to guess it's somewhere around -4. And it says, nope. Well, yeah, it's at -4. Ooh, -4.99. Maybe I didn't go over far enough. Maybe it's further that way. Better do this again. Second, calculate the minimum. That's somewhere between -6.5 and, see, I moved it over to there, and -2, and let's guess -5, and it says, oh, it does happen at -5. There's a minimum at -5. So this low spot is at -5. That was tricky getting that last part of that. Low spot's -5. Okay,